Good morning, ladies and gentlemen. This is section 8.7 and 8.8 of Mrs. Quinn's geometry class. And today we're going to start talking about circumference and areas of a circle. So first of all, I'd like to do some examples for you. Irrational numbers are numbers that can't be written as fractions, such as the square root of 2, or pi, or e. All of these are irrational numbers that have decimal points that extend forever, and we cannot write them as fractions. So if we want to write something as an exact solution, often we'll simplify a square root and we'll call it 6 square roots of 2. Or if we're finding a circumference, we'll write it as 9 pi. And we leave things, if we want an exact solution, in terms of that rational number. If we want a decimal solution, then we will have to approximate. But whenever you see the directions ask for an exact answer, you're going to leave it in terms of these irrational numbers, just like this. Pi in your circle, pi is a ratio between the diameter and the circumference of your circle, and we're going to use it for both your circumference formula and your area formula. Circumference is 2 times pi times r, your radius, or you can view that as pi times the diameter, either one. Your area is going to be pi times r squared. If we want an exact solution, simply leave pi and don't approximate it in your calculator. So let's find the circumference of a beautiful circle with a radius of 5. My circumference is simply going to be 2 times pi times 5. So I would get 10 pi as my exact solution. My approximate solution is, we're always going to go up to 2 decimal places. So if you're writing your approximate solution, you would write 31.4, let's round it up, 42. So this would be our exact solution, this would be our approximate solution. And let's give it some units. This is exact, this would be approximate. If you know a circle and you are told your diameter, now your circumference would simply be pi times the diameter, which is 7. This would be your exact solution. On your calculator, your approximate solution would be 21.99. Does everybody see the difference between exact and approximate? All right, let's move on. This is definitely an exact value. Your area of the square will always be exact. If we want the exact value for the area of a circle, I'm going to plug it into my area formula, pi r squared, and this is the exact value. Let's do it again in inches. This is the exact value of my circle. All right, we're going to talk a little bit about arc length. If I know that this angle right here is 90 degrees, and I know that this radius is, this radius right here is 10, if I want to find the arc length, I am going to have to find the circumference of my entire circle and then multiply it by the fraction I want. For example, if my radius is 10, let's go ahead and find the circumference of a circle. We'd have 2 times pi times r, which our exact value would be 20 pi. Agreed? Now notice that this is 90 degrees, and so of that 360 degrees, I only want 90. So I'm going to take my circumference of the entire circle, and I'm going to multiply it by 90 over 360. That's the fraction of the circle that I want. Now, I could actually reduce my fraction. 90 over 360 is actually 1/4. I could cross cancel. 4 goes into 20 5 times. And this would be the length of only 1/4 of my circle. And again, let's throw some units on it. We've got, let's say this was 10 meters. we'd have 5 pi meters as our exact solution. All right, no video question on 7-8, or 7-7. Let's move on to 7-8. If we want to give the exact value for the circumference of a circle with radius 10, I do believe, oops, we just found it. Our exact value of a circle with circumference 10 was right here, 20 pi. We would simply take 2 times the radius times pi, 20 pi. Find the radius of a circle with circumference 36. Now I'm telling you the circumference, and we're looking for the radius. So I set it equal to its formula. And I divide both sides by 2, and I get 18. And then notice that my radius is going to have to be 18 divided by pi. When you divide on both sides, this would be the exact value of your radius. If we asked you for approximate solution on your calculator, you could go ahead and divide by pi and give the approximate solution. When you are using pi, if you don't have a graphing calculator, if you haven't checked one out from the library, you're going to have to use 3.141 to 3 decimal places so that we're as close as possible to 2 decimal places. All right? Let's find the area of just this portion of my circle. First, I want to find the area of the whole circle. My area of the whole circle is going to be pi times 9 squared. That gives me 81 pi. And now, the portion of the circle that I want is only 110 degrees. So I'm going to divide that by how many degrees are in the whole circle, and this is the ratio of the circle I actually want. Here I could reduce, and I get 11 over 36. Here I could cross cancel. 9 goes into both. 9 goes in here 4 times, 9 goes in here 9 times, and my exact solution is 99 pi over 4 feet squared. All right. How about this red portion? If this red portion is the portion I want, first I'm going to find the area of the whole circle. And then I'm going to multiply that area by the ratio I want. I only want 240 degrees out of 360. And this fraction I could definitely reduce. I could reduce it by 10. And 8. Nope, hang on. 4. 4 goes into both 24 and 36. 4 goes in here 6 times. 4 goes in here 9 times. And, ooh, I could divide out also by a 3. I guess 12 had gone into both, right? If I divide out by 3, I get 2 and 3. So if I multiply this by 2/3, 2 times 29 is 58. And inches squared, this would be my exact solution. All right, what if we want to find the area of the green region? Hopefully we got a little bit comfortable with this in our probability section. To find the area in the green region, I need to take the area of the entire circle minus the area of the little circle. So the area of the entire circle, if this radius is 5 and this length is 12, the radius of the entire circle would be 17. So I'm going to take the area equals pi times 17 squared. 17 squared, I believe, is 289. And I'm correct. 289 pi is the area of the big circle. And I'm going to need to subtract the area of the little circle, which is going to be pi times 5 squared, which is 25 pi. When I subtract these, I end up with 264 pi, and my units are inches squared. And this would be the area of the green region only. All right, what if I want to just find the area of the blue region? Notice that I have a square here, so I want to take the area of the square, and I want to subtract these portions of the circle. notice that in each square I have 1/4 of the circle. This 90-degree angle means I have 1/4 of the circle in each. So I have 4/4 of the circle. So let's start off with the area of the square. Call it A sub S. This is my area of the square. Is going to be 6 plus 6 is 12. 12 times 12 is 144 inches squared. Now the area of the circle portions, I have 4 of them, and they're each 1/4 of the circle, so I'd have 1/4 times pi radius squared. 4 times 1/4 is 1. Pi times 6 squared is 36 pi, and my units are again inches squared. So the area of the blue region only would have to equal 144 minus 36 pi inches squared. And that would be my exact solution. For tomorrow, I would like you to find the area of the green region, and I will see you then.